All right. So, boom, we got our dictionary. It's just a bunch of letters. You can copy this wherever. Boom. Well, let me put it sideways so you can actually see that better. Then we've got our text prompt. That's just what the users get text. And then we've got our encrypted and our decrypted message. Those are the variables that we're going to be using when we actually print the encrypted, decrypted message. You get the idea, you get the gist. So we're going to move straight into the encrypting part because some people weren't here at class, so they might not have this. So what we're doing is we're going to create a for loop and we're going to do for I in text message. So I is going to be throughout the for loop, I is going to be every single letter in the text message. So if we type like hello, I is going to be first, it's going to be H, that's going to be E, then L, then L, then O, kind of like that. And so for I in text message, the computer is going to look at I, whatever the letter is. It's going to go up to the dictionary. It's going to find I as a value, or as a key rather. So let's say we're doing hello. Boom, it finds H. And it's going to drag out that value and put it into encoded message, or encrypted message. Sorry, I just mistyped that. So yeah, that's the way we kind of encrypted this, because we made the key specifically the alphabet and then the values just random symbols, because we wanted to make sure that the dictionary is translating the actual text, like the real shit, I guess. Like when you type actual words, that's gonna be drawing from the alphabet, and then when we call it in, and then when we do this code right here where we encrypt it, we want to change that to the bullshit. Pardon my French. So that's gonna be the brackets, that's gonna be the curly braces, the slash, the weird curly whatever that is, hyphen. So boom, that's pretty much how we encode the create the encoded message variable, and then we print it right here. So then we move on to decrypting, and this is where most people are right now, and they're kind of struggling with, I guess. So we start by doing our for loop again. Oh, this time we're gonna loop by encoded message, because now we're trying to go backwards, right? Because we have all the symbols, but we want to change them back into letters and and punctuation that we can actually read and understand. So the person who's receiving the text isn't just looking at it crazy. So we got our first for loop is I an encoded message. I explained why that's that. And then we're going to do a nested for loop, because we basically want to cross-examine each and every one. Like every time this loops around, we want to cross-examine each and every one of these dictionary letters or characters, what have you, with whatever's in the encoded message. And so normally, if you didn't do a nested for loop, that would take for each one of these keys, that would take an if statement. Let me put it like that. So you can see that's a lot of code. That's probably getting into like 60, 70 lines. To condense that, we just do another for loop, and that allows us, when we call this encode lets.keys, that's the name of my dictionary. But when we call that allows us to iterate through all of the keys. So we're iterating through all of the encoded letters, then we're iterating through all of the keys. So now we can kind of cross compare them, so we don't have to basically create a billion if statements. We can just stick within our loops. And it'll just keep going over and over and over and over and over until it reaches the end. So then we get to this little statement, and this is how we kind of get around the main issue of this program. Because the main issue is that you can't really reference a value in a dictionary by normal means. Or rather, you can't reference a value to get a key. You can reference a key to get a value, And everyone knows how to do that more or less. It's just like the dot, like LaFleur used the dot get thing. Sometimes you use like the sometimes like I use the hard brackets right here. You can use either way, but you can't call a value in and get a key. It's just weird like that. I guess it's kind of like how a square or a rectangle can be a square, but a square can't be a rectangle or something like that. If you know, you know. But basically, to get around that, we're actually gonna have to create a statement that compares with the value, and we're gonna have to manually take the key at that value. And that's why we're iterating through like this, because we need a surefire way for we need a surefire way to always have the key at whatever value we're looking at. And that's why we got J right here, because J is always gonna be the key at whatever, like J is always going to be iterating through the keys. So J is going to be A, B, C, D, blah, 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 blah. And so when we compare the values right here, and you encode let's at J, this is, like I said before, this is going to reference the value at the key J. So if J's A, it's going to reference, where's my finger? There we go. If J's A, it's going to reference this straight symbol or whatever. If J's B, it's going to reference the hard brackets. And if let's say I is the hard brackets, if it matches B's right here, the value at B, which is a hard bracket, then it's going to add that key. And since J's the key, then we basically can just skip around a whole bunch of bullshit and just get to the point. So it'll just keep running through like that until it gets to the end, and then we just print the decrypted message. So let's run through a test run just so you can like really get the idea in practice. So boom, we're entering a text message. Let's say something like, you look nice today. Little exclamation point. So boom, this is our encoded message, and as you can see, it's a whole bunch of jargon, but that's just what we want, because up here, as I talked about earlier, it's gonna look at each letter in the text message. As you can see, this is our text message, you look nice today. It's gonna go up to the dictionary, and it's gonna find the value at the it's gonna see if these letters exist as keys, and if they do, it's gonna find the value at their keys. So like the first letter was Y, it's gonna look for Y, it's the semicolon, and then it's like, okay, boom, add the semicolon to the encoded message, and that's why the semicolon pops up right there. And then it just keeps doing that. Then it decrypts, and as you can see, it comes back to a normal message. That's because we went right here. We went to the encoded message, which is all the jargon. And what the computer did is it said, if I in the encoded message, so let's start at the first instance, that semicolon. If that semicolon matches the value of whatever key J is, then it'll add it up. And then it'll add it to the decrypted message. So that's basically like saying the computer is going to check for each and every one of these keys. It's going to say, are you attached to the semicolon? Are you attached to the semicolon? Are you attached to the semicolon? It'll keep going all the way until it finds, boom, Y, you're attached to the semicolon. And once that matched, it said, okay, J is this little key Y. Boom. I'm going to add J to this decrypted message. And since J is that Y comes right down here. And then it iterates over and over and over again for every single character in space until it gets the full message. That's how it works.